Now, this illustration deals with ground fault protection of equipment in accordance with 230.95, which is service. But notice in the note 3, we are talking about a branch circuit in 210.13 as mentioned, and for a feeder 215.10. Now, let's review the sizing, maximum size, time delay and trip setting of ground fault sensors at the main service disconnect. Now, step 1, we're using the maximum time delay. We're using the MEL, which is your available energy level. We're using a 2,000 amp cycle for this good rule of thumb method. Step 2, the FLA, we take the kVA of the transformer times 1,000, divide it by the voltage times the square root of 3 if it's 3-phase. Now, doing this in the illustration, we know it's 480 volt, 277, so we're going to have 1,000 kVA transformer times 1,000 divided by 480 times the square root of 3. We come up with 1,203 amp. Now we're ready for step 3. We're going to look at the maximum ground fault amps, MFGA, equals transformer FLA times 6. So we take the step 2 FLA of 1,203 times 6, and for this method, the MFGA is equal to 7,218 amps, basically. Step 4, the time delay cycles. Step 1 divided by step 3. So 200,000 amp cycles divided by the 7,218 amps MFGA, we come up with a total cycle setting of 27.7 cycles. That's the maximum time delay cycles that we would set or could be set using the method we used when this first come out in 1975. But this is still a good method just to get a feel for what's going on. Now, step 1 in the illustration is the trip setting, so important. And if you should have 1,200 amps and somebody out on the job existing, you know, they get to messing with it and it's tripping and they just put it all in, which is not providing the appropriate setting in many cases. So it's recommended that 20% would be your max, so you'd set it 240. And if that trip setting did not work, then there's something else usually wrong. So note 1, contact your manufacturer and they will give you the maximum setting that could be used. Now notice in note 1, the trip setting may be calculated from 10 to 50% of the overcurrent device as long as a 400 amp setting is not exceeded. But again, today the manufacturer is going to tell you that, so keep that in mind. Then the example says the maximum setting, if we took 393.6 and multiply 1,200 amps by 33 1/3 to get that, we could, that's where the 400 amp setting come from with a main overcurrent device rating of 1,200 amps under, you know, certain conditions of use. And then the note 2 says the manufacturer usually would recommend no higher setting than 20% without them sending somebody out to see it. And then they may want to send somebody out to see it anyway. So you would contact them. And notice we've already talked about the note 3. So this figure 6-51B is showing the ground fault protection of equipment in accordance with 230.95, and this is how we used to set it when ground fault protection of equipment first come out in the 75 NEC 230.95, but then it was 230-95. So if you're having problems, check with the manufacturer, see if they'll let you set it up to 20%, or they want to come out and do it. This is very important to check with a manufacturer in accordance with 110.3 B and C of the NEC.